This time I made the Atbash Cipher. This was an interesting one because what's happening is you're actually just mirroring the alphabet that you're encoding from. So if you look here, A equals Z, B equals Y, C equals X, and the same thing here, A equals Z, or Z equals A, Y equals B, X equals C. And so I've literally just taken this top alphabet and flipped it, and the middle two letters are N and M. And so you can see that I've pivoted it from the middle, and that is what the key looks like. So if I were to take the message, this is a test, and we are on the encode, this is what the ciphertext would be. Now there's no shifting, there's no other information, so this one's a very, very insecure cipher because there's nothing else to do with it. There's only one key, period. Now if I go and decode, and I put this message in, again, so subscribe to One FinDog, there is nothing else to change. So if you know it's Atbash Cipher, then that's all you need to know. Looking at the code, we have our HTML. It looks very similar to the rest of the projects. We set the encode to true if they've clicked encode the cipher or the plain text. Automatically set that to checked. We'll set it to false if they click decode, and everything else pretty much goes from there. We have our on-change events for our plain text and our ciphertext whenever that gets changed. Again, we have our table and the table data elements that are being styled. We have our our text area inputs, our buttons, and then we have a wrapper. For the JS, very similar to before, we have our decoded and encoded alphabet. Yes, because there is only one key, I could make it where I just hard code the alphabet for the encode and decode, but I chose not to. We have a little bit of an extra encode there. Get rid of that. Again, we have our capital A through Z regex, and whether our encode is true. We set the encode alphabet again, decode an alphabet, which is just going to be A through Z. We set the encoded alphabet by encoding the letter and sending in what the original letter is going to be. For display alphabet chart, we call the set decode and the encoded alphabet. We have a top row and a bottom row that is empty for the display chart. So we cycle through the alphabets and we show them. So we have our top row and our bottom row. And then we actually show we add the rows to the inner HTML. To encode the text, again, clear out plain text, and the ciphertext. Well, actually, we set it to uppercase. Then we grab that from the plain text. We clear out the ciphertext, and we cycle through the plain text and add the encoded letters to the ciphertext. The way we get there, we send in the character, and then we test to make sure that it is a letter in the uppercase. If so, then we take 25 minus the letter code minus 65. So now we have 0 through 25. We take 25 minus that, and then add 65 to it. So for instance, if the letter code was 65, which means it's A, we subtract 65, which makes it 0. We take 25, subtract 0 from it, leaves us at 25, which would be Z. We add 65 to get it back up to ASCII code, and send it. For instance, if it was B, B would be 1, subtract 65, that gives us 66. Sorry, yeah, it would be 66 minus 65, so it gives us 1. 25 minus 1 would be 24, which gives us Y, so add 65 to get back that ASCII character. For decode, it's basically the same thing. We make sure that the ciphertext is in uppercase. We grab that ciphertext. We clear out the plain text. And we decode each letter. And it's actually the exact same formula to get back the plain text. We have our encode decode. So to encode the text if we are set to true for encode, and it will decode it if we are set to false. We set the encode here, send in the value, and then call encode decode. And at load, we have Atbash load, which just calls display alphabet chart.